Alright guys, this is day 2 of our exponential functions, and last time we kind of learned a bit about this formula y equals a times b to the x, right? That's our general exponential equation formula, and the two things that are important about it is the a and the b, right? The a is your starting value here, right? Your b is your base. Now the base is generally the harder piece to find, and we're going to have to identify both of these with the examples we're going to be seeing. But first I want to kind of give a little bit of talk about the growth and decay here. So a growth function, this is going to be where that base is greater than 1. So a quick sketch of what these look like is going to be an increasing function over time. Some key words is a population increases by a certain percent, right? Now, if they say it increases by, let's say, 5%, we want to recognize that increase of 100% plus that extra 5% gets us this 105%. And if we convert that to a decimal, we're going to get 1.05. And that is what our b value is going to be in a scenario where they're saying it increases by 5%. Now decay is the opposite guy. Now this is going to be where b is somewhere between 0 and 1. Quick sketch of this guy would show it that it is decreasing over time. So you might hear some words like it depreciates. Depreciates is a decay example. So let's say it decreases by 2.3%. Well, we want to recognize that that 100% is going to be reduced by 2.3%. Here we'd get something like 97.7%. And then we want to convert that to a decimal, which is going to be 0.977. And if you're at all unsure about how we convert from this percent to decimal, we just move this decimal point 2 to the right, and that gives us that 0.977. So you want to be able to recognize if they're increasing, we want to increase that whatever percent they give us, increase that to 100, then we convert that to a decimal. If it's depreciating or decaying by a certain percent, we subtract that from 100, and then again we convert that to a decimal. So we're going to look at 4 different examples, 2 that are growth and 2 that are decay. So a town has a population of 14,000 and grows at 3.5% every year. What will be the population after 14 years to the nearest whole number? So let's start off with our y equals a times b to the x. Let's try and identify those a's and b's. So a is the starting value. Well, it has a population of 14,000. That's where we're starting from. That grows, so we know this is a growth idea. So we want to add that 3.5% to 100. Here we'll get 103.5%, and then we convert that to a decimal to 1.035. Again, we're just moving that decimal point 2 over. So we've got our base now, that's 1.035. So we can create that exponential function now that we have a and b. A is 14,000, b is 1.035 to that x. Now that doesn't answer the question because they want to know what the population will be after 14 years, right? Well, population is the y. We want to know what the y is going to be after an x is plugged in of 14. So we want to plug that 14 directly into our function. And if we type that into the calculator, that gives us about 22,661.72. But they said round to the nearest whole number. These are people. It would be a little weird to have 0.72 of a person. Are we going to round that 1 up? Yep, the 7 is big enough to round it up, so we are going to get a population of 22,662. All right, so that's our first growth example. Let's take a look at a decay example. Now this one here, they talk about depreciates, right, which we said was a decay example. So a new car is purchased for $19,900. The value of the car depreciates at 7.5% per year. What will the value of the car be to the nearest cent? Of course, we always want to round to 2 decimal points when we're talking money, after 8 years. So again, let's create this equation. Y equals a times b to the x. We want our starting value. We want our base. Starting value? Well, it was purchased for $19,900. That's where we're starting. But this depreciates at 7.5%. We want to take that away from our 100%. So if we do that, we'll get 92.5%. Now we want to convert that to a decimal. Again, we just moved that decimal twice over. 0.925 should be our base value. So we plug this all in. We've got our A now. We've got our B. And now we've got our equation. But again, that doesn't answer the question. They want to know what is the value of the car to the nearest cent after 8 years. So what we've got to do here is we got to plug in that x equals 8 and find out what the corresponding y is going to be. So 19,900 times 0.925 to the 8. Now make sure when you plug these into your calculator, make sure you do this part first, then multiply by the 19,900. If you don't, your order of operations will be off and you'll get a weird answer. So if we plug this in, we should get 10,665.64 if I round, and that would be the price to the nearest cent after 8 years. So again, this example depreciation, we want to be subtracting from 100%. All right, we've got 2 more examples to look at. You place $8,300 in an account with an annual interest rate of 6.5%. How much will be in the account after 14 years? To the nearest cent. Of course, again, money, we want to round to 2. Now, annual interest is money you gain, right? So this is an increasing function. So we're looking at growth. Y equals a times b to the x again. What's our a? What's our b? The a shouldn't be too bad to find, right? That's what we're starting with, the 8,300. Now, because this is interest, we are gaining this. That 100% is being increased by 6.5%. We get 106.5%, and then again, we convert that to a decimal, 1.065. So we get 1.065 for our base there. Now we just directly plug those pieces in. 8,300 is the A, 1.065 is the B to the X. Now we need to plug in 14 years. 14 years is going to be our X value. We plug that directly in. And again, make sure you're using your order of operations properly. So when we plug in 14 here, we're going to want to do 1.065 to the 14 first, and then we want to multiply by that 8,300. That should get us about $20,043.46 if you round that. So you guys can plug it in and see if you get the same thing. You should be getting this $20,043.46. Again, make sure you're always rounding to 2 decimal points when money is involved. Last example to look at is this elemental decay, right? So an element with a mass of 730 grams decays by 15% per minute. How much of the element is remaining after 10 minutes? To the nearest tenth of a gram. So again, we want to start off with our standard y equals a times b to the x. Identify a, identify b, and we're good. So it starts with 730 grams. That's our starting value. Decay means we're losing. So take that 100%, subtract 15%. Oh, I added. We would get 85% here. And again, convert that to a decimal. Remember, with a whole number, the decimal's at the end. So we would move that 2 over. We'd get 0.85. So our base here is 0.85. Now we've got our A and our B. Let's just plug it in. A is 730. Times b is 0.85 to the x. Again, not the finish. We want to know how much of the element is remaining after 12 minutes. So we're told that x is 12. We plug that in. you get 730 times 0.85 to the 12. Again, order of operations is key here. Don't multiply the 730 and the 85. The 0.85 needs to be raised to the 12 power first. So this here is going to get us about 103.836, but they said nearest tenth of a gram. So we're rounding to this 8. That 3 is not enough to bump it up. 103.8 grams would be our final answer here. All right, so the big key, big takeaway that we want to get here is that if it is increasing, we want to take our 100% and add whatever percent it's on. And if it's decreasing, we want to take that 100% and we want to subtract, right? And then, of course, we want to make sure we convert to a decimal. That's going to help us find our B value. All right, we'll be doing more of this next week as well.